we have a circuit like this, where VCC is going to be 10 volts. I'm going to change that. I'm going to change it to 9 volts. Can you change the VCC value to 9 volts? The reason why I'm changing it to 9 volts is I have a circuit exactly like this in the lab this week, and it's going to have 10 volts. So I'm going to use 9 volts in class, so you can look at these notes here and figure out the circuit for the lab with 10 volts. Okay, so VCC is 9 volts, HFE, which is the current gain of the transistor, is given to be how much?
150.
150. IC max, this IC maximum is given to be 10 milliamps. What we're going to do is design a circuit. Designing means that I want to build a circuit, but I don't know the values of the components. I don't know the size of RB, I don't know the size of RC, so that's what designing any circuit means. So that's what we're going to do. Calculate RB, calculate RC. So this is kind of working backwards. Given the external parameters, let's find out now how to calculate the values of RB and RC. So first calculation, or let's first draw the graph. Let's first draw the graph. So on the right-hand side, label the x-axis VCE, the voltage from the collector to the emitter, y-axis IC, the current in the transistor in the collector. Oops. Let's draw a straight line connecting from one end to the other end. This end is cut off, which is where the transistor acts like an open switch. Over here is saturation, where the transistor acts like a closed switch. 0, where the two axes meet. When the transistor acts like an open switch, what is the voltage in this circuit? 9 volts. So indicate 9 here, 9 volts. Saturation is given to be the maximum. Saturation and maximum are one and the same. The maximum current is the saturation current, which is given to be 10 milliamps. So write down 10 milliamps. So given 9 volts at this end, 10 milliamps at the other end, now let's go right in the middle, right about here. Come down 50%. Midpoint. Midpoint is 50%. How much? What's VCE? 4.5 volts. IC, midpoint, 50%. How much? 5 million. Okay, so that's my graph. Midpoint bias. Why are we doing this midpoint bias? Because we will be learning that when it comes to designing a transistor amplifier circuit, then if you go back to page 7, bottom of page 7, there are a couple of sine waves that are shown. We'll come back and revisit this graph because right at the midpoint, we get the maximum amplification out of a transistor circuit, okay? So that's why we're designing where this midpoint is important in our study of transistor circuits. Yes?
Isn't the cutoff voltage 10 volts?
I changed it.
Oh.
I changed it to 9. So can you change it to 9? Okay. So VCE cutoff, 9 volts. Midpoint. 9 over 2, 4.5 ohms. Okay, second calculation. Third calculation, IC sat, which is IC max, 10 milliamps. Therefore, IC midpoint, 4.5 over 2, no, 10 over 2, 5 milliamps. Make sense? Okay, so far so good. This part is easy. Now, we find out the values of RB and RC. So the first value I'm going to find is RC. So I've got this circuit here, where basically I have RC and collector to emitter is 4.5 volts. So I'm going to find, and I know the current, it's 5 milliamps. So therefore, how much is RC? RC I find using Ohm's law, V over I. Okay? Voltage across RC is the total voltage minus what? The voltage at C to E. So that's VCC minus VCE. I is IC. Everybody see that? Total voltage minus the voltage from the collector to the emitter is the voltage at the resistor. Voltage divider, right? This is my voltage divider. If this is 9 and the voltage here is 4.5, then the voltage at RC is 4.5. So it's 9 minus 4.5 divided by 5 milliamps, which is how much? What do you get? 900 ohms? Okay, so that's one of the two resistor values that are unknown, 900 ohms.